Welcome to the Angular 2 Essentials video course by Pact Publishing. I'm John Munch, a professional software developer for over 29 years. For the last few years, I've worked as the lead front-end engineer and architect at a startup creating a marketplace for negotiating medical supply contracts online. The front end of that software is, naturally, written in JavaScript and AngularJS. Previously, I authored the video course Learning AngularJS Directives for Pact Publishing, and I've also written some small, open-source AngularJS projects, which are available through my GitHub account. This course is about Angular 2, a framework you can use to build sophisticated front ends for websites. This video is an overview for the entire course, which covers not only Angular 2 itself, but many of the tools you will need to or want to pair with it, and advice on how to build JavaScript front-end applications. You'll get a running start on Angular 2 itself, and in the first section, get your machine configured for developing and putting together your first application. You'll also see how Angular 2 structures your entire app out of components. In the second section, you'll see how Gulp is used throughout to automate the building of your software to make your development life easier. In sections 3 and 4, we'll dig deeper into building components, pipes, routing, and more to help you understand the pieces you need to build real applications. Section 5 is all about advice for building advanced JavaScript applications. I've talked with a lot of developers and management over the years, and I try to clarify some of the repeated misunderstandings I've encountered over that period. Section 6 covers both debugging your apps and testing them, because every developer makes mistakes. And finally, Section 7 talks about using a continuous integration server and shows you some of the basics of automating your development operations so you can work as a team and work faster. I want to get you familiar with Angular 2, but to make sure we don't skip the things which I believe go with it to set you up for long-term success. That means you'll leave this course comfortable with having Gulp run your build process and have used tools like Ansible to set up a server and deploy your software. This course does not expect you to already be familiar with AngularJS. In fact, you'll hardly ever hear me mention version 1 of the framework, but you will need to be very comfortable with both JavaScript and HTML before starting. Angular 2 gives you what you need to be able to build web applications today using technology from tomorrow. Let's get started exploring and developing with new tools in this cutting-edge front-end framework. Hello and welcome to Angular 2 Essentials. In this section, we will learn the parts of an Angular 2 component and how it uses that one piece as the backbone of the framework. Then we'll set up a development environment enough to be able to create our first component. Finally, we'll enhance that component by having it call a remote API, adding Angular 2 dependency injection, and talk about the use of JavaScript classes in Angular code. Now we move on to the first video of this section that deals with making a UI out of components. In this video, we're going to take a look at understanding Angular 2 components by going over a cheat sheet of the parts to one and seeing what each one does. But we'll also go over the central role that components play in the Angular 2 ecosystem. The fundamental part of Angular 2 is the component. Components are a way to extend HTML with new elements specific to your needs. By default, HTML is pretty generic. Everybody gets the same divs, inputs, tables, etc. This is a typical bare-bones search in Bootstrap. Take note of how much HTML and CSS are needed to make it look like what we want. And this is not a fancy control. Angular 2 gives you the building blocks to add this as an all-new element to your HTML so that you can type search form instead, or social media links, or cost graph, or whatever are the fundamental pieces of your web application. Angular 2 took that idea, which we had seen previously in frameworks like AngularJS 1 and React, and scaled it up to say that the process of building an entire application is the process of breaking it down into a tree of components with one application component at the root. The other components it uses may in turn be built out of other components, and so on and so forth. But let's not get ahead of ourselves. Before you start building entire web applications out of components, you've got to build one component and understand it. First, I'm going to go very briefly over the parts of a component in Angular 2. Here's what I call my component cheat sheet. It is some of the most common settings and parts which make up one, and there are many. Fortunately, they can be grouped into two major sections. First is the @component annotation. Here, we define what this component is going to replace in your HTML. Other components and directives we need to inject into this component so it can do its work, and the properties and events it's going to expose on its surface so other code can connect to it. In addition, it has a template associated with it. That's the HTML we want to use to render our component. Or if our component is large, we might choose to refer to a separate file for the HTML. We can also do the same with CSS for our component, which is either embedded or kept in a separate file. Finally is a class, a simple, straightforward ES2015 JavaScript class. You may choose to put some additional notations on it for TypeScript to mark the types of properties, parameters, and return types of methods, but you can skip them for the moment if you aren't yet familiar with TypeScript. The class contains the code which drives the functionality of the component. If it's your application component, it's probably going to have code related to the high-level views in your app and coordinating how everything appears and disappears. If it's a tiny component, like a thumbnail image the user can click, it might have very little code. The code for a search form might have validation code, rely on another service class to execute API calls to servers, and be much more sophisticated. In this video, we've learned about the @component annotation and the class that make up a complete Angular 2 component. Excellent. In the next video, we'll get your machine set up so you can start building your very first component. In the previous video, we looked at components in Angular 2. In this video, we're going to look at getting set up to do some Angular 2 development. Specifically, we'll look at why we need to do any setup at all, talk about the different versions of JavaScript, past and present, and install the tools we need for our development workflow. If any of the JavaScript you saw in the last video looked unfamiliar, then you need to understand that Angular 2 was written by the Google team using a language called TypeScript. TypeScript takes the current version of JavaScript, known as ES2015 or as ES6, and adds some additional features. Even though Google used it for their library, you do not have to use TypeScript for your code. They provided a way to use ES5, the last version of JavaScript, instead if you prefer. However, this course does not focus on building Angular 2 apps with ES5, because ES5 is the past and ES2015 is the future. And Angular 2 is all about the future. But you may be wondering how we can use ES2015 or TypeScript or anything other than ES5 when that is what the current browsers support. The way this works is that TypeScript is a transpiler. You may have previously worked with a compiler in other languages. For example, Java and C++ are both languages which are compiled from a high-level language to a simpler language which gets run on a real machine or a virtual machine. A transpiler is similar to a compiler, except that it does not compile from a high-level language to a low-level language. Here is an example where we see TypeScript converting a very simple ES2015 feature, the template string, to some ES5 JavaScript code that can do the same thing. The first form is easier to write, especially if you're doing a lot of string assembly. The second form is JavaScript compatible with current browsers. But it's not just simple stuff which can be handled by TypeScript. Many ES2015 features such as classes, arrow functions, generators, and more can be rewritten into ES5 code which you can deploy to servers and know that your users will be able to run them today. If you do not know ES2015 yet, don't worry. You will not only pick up some just from seeing me use it in this course, but I will also be providing some suggested sources for you to learn more because you're really going to want to master it eventually. It is the current version of JavaScript and it offers some really great improvements in syntax or capability over ES5. I could spend quite a bit of time on setting up your machine, explaining tools, etc., but I'm going to delay that until later. At least for the first section of this course, I'm going to skip and reduce that as much as I possibly can to get you to the framework quickly. Also, once you've gotten a taste of Angular 2 development, then coming back to topics like build tools, configuration, and setup is going to seem a lot more palatable. We're going to install everything we need in 3 steps, and then we'll start our server before we begin the next video. First, go to nodejs.org and download and install Node.js. This will get us an engine capable of running JavaScript code from the command line, running servers, and installing all the other JavaScript tools and parts we need to do our later work. Second, run npm install-g gulp-cli TypeScript to install both the global part of the Gulp build tool and TypeScript. Don't worry if you don't know what Gulp is yet, we'll be talking about it in later videos. If you're on a Mac, as I am, you'll probably need to add sudo in front of that command so it can install the tools for the entire machine. Third, go to the section 1/video 1.4 directory in the Mastering Angular 2 source code and run npm install to install all the JavaScript packages on which our project depends. You won't need sudo in front of this command because it's installing everything in this directory. You're done with installation. Yes, it's that simple. At this point, you can run Gulp to both start a server and start watches, which will process the TypeScript files and refresh the browser automatically. It even launches a browser so we can start editing the code and see the results immediately. In this video, we've explained why you need to have some tools installed on your machine and install them so that you can begin development. In the next video, we'll use the tools we just set up to build your very first Angular 2 component. In the previous video, we learned how to install the software we need to develop an Angular 2 component. In this video, we're going to take a look at how we'll import the pieces we need into our code, write the shell of a component, and give it the ability to do something. Then we'll hook it into our web page so we can see it actually work. If you've done much JavaScript development over the last few years, you know that managing the multitude of files and libraries you needed could get to be a bit of a pain. You likely found yourself adding dozens and dozens of lines to your HTML to pull in library files from content delivery networks around the web in your own script files. In some of my own pages, it was not unheard of to have it pull in 75 plus individual scripts to get all the JavaScript for a single page. But thanks to ES 2015, not anymore. It added modules, so now our JavaScript code can specify which other JavaScript code it needs, and it will get loaded on the fly. The HTML doesn't have to be edited over and over again to add dependencies. Let's see that first fun part to component development by editing our HTML to add the minimal number of files it needs. The code I'm adding looks pretty mystical, but what it's doing is actually straightforward. It loads a file designed to add functions which may be missing from some older browsers, add in some libraries Angular 2 needs, and finally pull in the module loader, System.js, so that we can use module loading ES 2015 offers right now in browsers which don't have that feature yet. It handles emulating that for us. From that point, we're just loading some configuration for System.js and telling it the name of the very first module it should load. In this case, we've named the module app, and the systemjs.config.js file tells it what file it should load for that module. With that done, we can turn our attention to the TypeScript code. We'll use the import statement to pull in classes we need from the Angular 2 library like this. And here are the first set of classes we'll need. There's component, which we saw earlier when we were looking at the Angular 2 component for the first time. In addition, there's bootstrap, which we'll come back to later in this video. With our dependencies handled, let's add a skeleton component with no details filled in yet. The name of our component is the very original Hello World. Now we can start filling in just a little bit of the material needed by our add component annotation to get started. We have to have a selector because it tells Angular 2 what to look for in our HTML. When Angular sees an element with this name, it will put our component in that spot and hook it up so it runs. We already had an element in our HTML named app, so we'll use that as the selector for our component. Now we'll fill in a template for the component. We're using the backtick symbols, which ES 2015 uses for string templates, to put our template in line easily. It's a handy way to do it because we can format it across multiple lines without having to make individual strings which we concatenate with the plus sign. And finally, we add the bootstrap command we imported earlier. Don't confuse this with Bootstrap, the HTML and CSS framework we use for layout. This is a command to tell Angular where to start building up its tree of components. In this case, we only have one component on the page, so it's not complicated. At this point, we should be able to go over to the browser and see our app running. Congratulations! You've just built your first Angular 2 component. In this video, we have built your very first component using Angular 2 and seen it running. In the next video, we'll look at how we can inject code into our classes to make them easier to assemble and easier to test. In the previous video, we learned how to build your very first Angular 2 component. In this video, we are going to take a look at building upon that to create a component which displays a list of users, populate that list with some canned data, and then look at what it takes to separate out our data model from the component which uses it. Hello World is just fine for the first component we ever build, but for a second component, I think we all agree that we should tackle something with a little more substance. To start off this video, I've got our HTML already set up in a single app component which acts as our parent for the one we're about to build. So right off the start, we're going to have a more realistic example because now there will be two components rather than just one. To get started, we'll create the file userlist.component.ts and start plugging in the pieces we know we'll need here. For example, as with our first component, we know we'll need to import some pieces from Angular. Now we can put in the basics of a component here and make sure we're exporting the class so we can import it elsewhere. In addition, we're going to make use of template URL this time when we're specifying the template for this component because I don't really want to embed a large amount of HTML directly into the JavaScript. If we specify a template URL, then Angular will load that file and use its HTML for our component. We'll call that file userlist.template.html and start it off with some HTML and CSS from the Bootstrap project because it has some layout examples that give us a reasonable representation of media items that could serve as our users and a pagination control we can use. At this point, we can go back to our app.component.ts file and import the new component like so. If we add our new component to the list of directives for the app component, we could use it right now. But we're not going to do that quite yet. We just want to make sure everything still executes smoothly. It does, so let's use the new component in our app component template. And that's good as well. We finally see something, though without any data it's pretty limited. We need to add some data to the component, so we see something. We do that with some canned values here. You might be wondering about the structure of this sample data and thinking it seems more complicated than it has to be. That's because I'm making it look like the data we're going to get remotely via an API in the next video. That data comes in separate pages of data, so we'll simulate that for a couple of pages. Now that we see our component actually rendering some data, we should reflect on the fact that we've tied our data directly into the component itself. That's not a good thing. It would be much better if all the data came from outside the component. With that in mind, let's remove all the mock code from our user list component and make sure we can import our new service class instead. And then we'll create a new class, which we import into the user list component to act as that model. And then we'll paste in all the code we just removed from the user list component. You'll notice that there's nothing really unusual about our class. It has no annotations, no special code to be used by Angular. It's an ES6 class and nothing more. Angular makes as much use as it can of ES6 classes to underpin its code. Even components are fundamentally a class with some annotations. The more your code makes prudent use of separate classes, testable classes, the happier you will be. The code we've added to our user list component just instantiates the user's service class and passes through all the function calls to it. Now we can refresh our page and we'll see exactly the same thing we saw before, but our component is free of our mock code. Great work. In this video, we have created a second component, which displayed data, extracted a data model from it, and made the component use the new data model for data access. In the next video, We will build a new version of the user service which uses a remote API and then plug both versions into Angular's dependency injection system. Hi there, welcome to the last video of this section, Injecting Dependencies. In the previous video, we created a more sophisticated component and wired it to a model from which it could pull data. In this video, we're going to take a look at creating an interface which our current mock object can implement, building a new users class which uses HTTP to retrieve remote data, and then using Angular's dependency injection system to switch between them. There are many reasons why we may need to switch between different implementations of the same code. One of the most common is when we first start on a user interface. The APIs we need are often not available yet, so it's not unusual to make mock versions like the model in the last video, which served up fake data. Once early versions of the API become available though, we may want to switch back and forth between a fake version of our model and a version which uses the API. So let's see how we can do that here. The first thing we do is split out an interface from the model we created last time. Every version of the model, whether real or fake, will implement the same interface, and the component will use only the interface rather than any concrete implementation. In this case, it's really simple. If we ignore the constructor, then there are just 3 functions we need on the interface class. Then we rename our mock version to a new class name and indicate that it implements the interface. Now we need to create a new version of the interface. This version will not use the mocked up data, or rather it will, but it will be fake data we pull from a remote source. recres.in is a site which offers a set of simple API endpoints which serve up some fake data for you to use when you're first mocking up your user interfaces. We'll make use of the function to get a list of users a page at a time. The data returned from it should look familiar because it's the same layout as the fake data we used in the previous video. The new class will implement the same interface as before, but now in our page function we'll make a remote request to retrieve data from that API. That requires importing some more classes from Angular's wrappers for HTTP into both this services file and our app.component.ts. We'll include HTTP providers in our Bootstrap call. Now we can make use of HTTP in our new class by injecting it into its constructor. We'll fill in functions we expect the class to implement. And then we'll fill in the constructor and the page so they make use of HTTP to provide an API-based implementation. Awesome! Note that Angular is using observables from the reactive extensions for JavaScript project. If you've used promises in the past, observables are very similar, except that they can deliver one value or a stream of many values. So they are capable of everything a promise can do and much more. Isn't that great? We will come back to them in a later video, but for the moment, you need to know that what comes back from HTTP calls is an observable from RxJS, and the map function we used was part of its many functions. Rather than implement the data and pages functions again, when the code is going to look just like what users mock has, let's just move that shared code to the users class instead. After all, we indicated both implementation classes extend the users class, so any code in that class will be available to all the children. We can now make our user list component inject the interface as the thing it wishes to hook to, without it knowing which implementation it will get. Rather than go test out our new class by modifying what the user list imports and wiring up the new class, let's skip directly to trying to make use of Angular's excellent new dependency injector. We'll add imports for the user's interface and all of the concrete implementations, but how do we tell Angular which one we want injected? When you bootstrap the application, something we're already doing at the bottom of app.component.ts, you can give Angular some instructions about how it should handle its dependency injection. We saw a little bit of that a minute ago when we used HTTP providers to give it a hint about the setup we want for HTTP. Now we'll add another binding, and I think you'll find it very easy to understand what it's telling Angular to do. We'll add code to bind requests for the interface to a specific class we want injected for those requests. At this point, you would be forgiven for expecting our code to work. There is, however, one missing piece. Angular 2 does not include all the many functions available for RxJS all the time. So the map function we used when we were creating users HTTP is not going to be available when we want to use it. To fix that, we'll add an import for RxJS. Now when we refresh, we suddenly see a new set of data in our component. Or we can switch back to the mock version as easily as changing this to read users mock instead. So now we could tie the version we want to use to a cookie stored in the browser or local storage, or even pass something into our page in the URL to indicate whether we want to use real API calls or mock data. I'm sure you'll appreciate how even with this small example, we now have significant control over how our app is wired together at runtime, and something that used to be much more complicated is now provided for us. In this video, we've created multiple implementations of a single model which provides data to our component and switched them out using Angular's dependency injector. In this section, we've started to understand how an Angular 2 app is put together, gotten set up to do development, created some components, and exercised both the ES 2015 module system and Angular's dependency injection. In the next section, we will return to Gulp and look at what it's doing for us and how we use it to build a development workflow. Hello and welcome to Section 2, Constructing a Workflow. In the previous section, we built our first component and looked at the central role components take in Angular 2. In this section, we'll go over the build tool we're using in this course, Gulp. Explain why Gulp was picked rather than the equally popular tool Grunt. Explain the gulpfile.js you've been using and provide some links and hints for taking the existing file and giving it more capabilities. This video is about using Gulp to drive your build, something we're already doing. We're going to take a look at what we get from using Gulp and what it can be made to do, why I picked it instead of Grunt, and take a momentary side trip while I extol the virtues of learning a little bit about Node.js. The main reason you have a build tool in your development today is the conversion of TypeScript to ES5. Without that, you could technically skip a build tool altogether. However, this is a course about mastering Angular 2 and building large projects with it, not just figuring out the minimum we can get by with. I don't really know of any big projects I've seen which don't have a build tool running automatically for the team as a whole, and these days it's normal to run something locally too. That's because there are a host of reasons you might want to use a build tool in your workflow even if you don't have TypeScript code to process. Human beings are terrible at boring repetitive tasks. Computers excel at them. So what can we get Gulp to do for us that we might waste time doing manually more than once? Copy, rename, remove files from where you work on them to destination directories where you assemble what you actually intend to deploy. Automatically reload your browser or several browsers at the same time when you save your files. Run a tool like tslint on your code to catch potential coding mistakes in your TypeScript. Use a CSS preprocessor like Sass or Less. Both of these are similar to the transpiling we do with TypeScript to ES5, and they convert a language with new features to CSS styling which current browsers can handle. Send notifications to you through your operating system to let you know if errors occurred or specific steps have been accomplished in the build. Concatenate multiple JavaScript files into one and make the file as small as possible to make it a quicker download for the end user. Run servers. And that list barely scratches the surface of the plugins and capabilities of Gulp. Now you might ask, why Gulp rather than Grunt? And the answer is that each tool actually works differently. Grunt is very similar to classic build tools like Make or Ant. It sequences a set of actions for you so that you don't have to execute them manually one at a time. Gulp is fundamentally different because it sets up a pipeline of actions in memory and sends data through them without having to write intermediate values to the file system after each step. Thus, Gulp can be, if you use it right, faster than Grunt. And now a quick word about Node.js. I've just been talking about Gulp and Grunt and how they're different, but they're also quite alike in some ways and share something with other tools like Karma, Mocha, Protractor, the Node Package Manager, etc. All of them are written on top of Node.js. Although it was intended originally as a tool to build web applications, the Node.js JavaScript engine has proven to be equally adept at all kinds of application development. Node.js, plus its hundreds of thousands of available libraries, has become a Swiss Army knife for the JavaScript programmer. Node itself handles loading and running the JavaScript code, provides a package manager for easy installation of the libraries, and it works as well on the command line as it does for building web user interfaces. Even if you never use Node.js to build a single web app, learn it a little bit at a time because it will help you with all these tools which are built using it. It may also help you because you may find yourself wanting to build an administrative tool or do some mining in your data, and you'll suddenly realize that if you just create one small piece of code, Node and its libraries can do the rest. In this video, we have gone over the reasons for using Gulp as a build tool, its extensive capabilities, and briefly covered why you might want to look at Node.js even if you never use it to build a web server. In the next video, we'll go over the sections of our gulpfile.js so you can see what it does and how you could extend it to do more. Hello! In the last video we learned about Gulp itself. In this video we'll be looking over the gulpfile.js we used in section 1. We'll look at how we load the plugins Gulp uses, how to use Gulp to build tasks and link them together, what our plugins are doing for us, and how we can trigger the tasks to happen automatically when files change. In the first section of this course, we used Gulp and TypeScript to handle transpiling our code into something our browser could accept, but we didn't spend any time looking at the gulpfile.js to see what it did or how it did it. Now let's take a quick look at what it's doing so we can get an idea how it works. In the first section of the file, we load Gulp itself and the 3 plugins we're using in this very simple example file: Browser Sync, Del, and TypeScript. Then we define our paths to various types of files within our project. Next, we come to a series of different tasks named Clean, Scripts, Other, Browser Sync, Watch, and Default that we want Gulp to be able to perform. Clean scrubs the distribution directory, so we've reset back to a starting point. The Scripts task picks up all the TypeScript source files, pipes them through TypeScript for transpiling, and then writes the results back to disk. Other also copies files, but does so without any changes. The Browser Sync task starts up Browser Sync and points it at the location where all the processed files end up. This one is really interesting because it doesn't just provide us with a server for our files. It also syncs our actions within the browsers. For example, you could be running 3 different browsers, all connected to the same copy of Browser Sync, and when you click on a link in one browser, all 3 react at the same time. You can cut your testing time significantly with a tool like this, especially when you're trying to do a layout for a responsive site and you can see it simultaneously refresh on your phone, a tablet, and your desktop all at the same time as you work. The Watch task sets up 2 different watches. One of them watches for changes to the TypeScript files. The other watches for changes in all the other files we need to deploy, for example, CSS or HTML files. If any of the watches fires, another task is executed, and then a signal is sent to Browser Sync to reload the web page so you can see the results immediately without even having to leave your editor to click on the browser to refresh it. 2 other tasks are used to make sure that we've completed the transpiling or copying before we do that reload. Finally, there is the default task. It is the task which is run automatically if we just run Gulp without specifying any particular task to run. It has an array of dependencies listed after the task name, and it will run all of them. Other than making sure all of the other tasks get started, it has no actions it takes. From the command line, we can run any of the tasks directly. For example, Gulp scripts, which would just process all the TypeScript files once and exit. Or we can run Gulp, and all our TypeScript files will be processed, Browser Sync will be started, and watches will begin watching for changes to any of the assigned set of files. Gulp has managed to do all of this with essentially just 4 commands: task, source, dest, and watch. That simple vocabulary is both easy to learn and gives you a lot of flexibility if you combine it with some of the army of Gulp plugins I showed you in the last video. I also want to point out a link that's right at the bottom of the docs to a library of recipes for common needs lots of people have. I'll be providing it as a separate link in the README file for the course to make it easier to find because it's very useful. In this video, we went over the provided gulpfile.js, and in this entire section we learned why we're using it, why we picked it, the many things it can do that we aren't making use of yet, and a few starting places to begin using that power later. In the next section, we'll take what we've established and focus on Angular 2. Hello, welcome to Section 3, Focusing on Angular 2. In this section, we can make use of the foundation we established in the first 2 sections to start looking at all the major pieces Angular 2 gives us to build our applications. Specifically, we'll look at the core directives it gives us, building forms, and return to making remote API calls. The first video in this section is about creating a component from an existing web page template and dealing with a few things we have to do differently in that case versus an artificial hello world type example. In this video, we're going to take an existing template for an admin dashboard and quickly convert it into a component. After we do that, we'll see a couple of problems with the results, and we'll use features of the component to address both of them. Before I did this part of the course, I looked at a lot of admin templates because there are dozens even if you restrict yourself to those which are free. If you expand your search to include commercial ones, many of which are less than $50 and look very nice indeed, you've probably got hundreds of choices. But the one I settled on for this course is one offered as an example of Google's Material Design Lite. Material Design is a design pattern and style which you see both in Google's online properties like Google Inbox and Google Search, as well as many of their Android apps. Google actually makes available several different versions of Material Design, of which Material Design Lite, henceforth referred to as MDL, is only one. One of the reasons I've picked this is that you can make use of some of the other components to extend this if you decide to build upon what I do in this course later, or if you see some things you like and might use them yourself. I've gone ahead and downloaded the template you see here and set it up as our starting point for the video. Now that we have the template working, we'll convert it into an Angular 2 component in no time. First, we need a TypeScript file to hold the component. Next, we must import the component from @angular/core, which we've done before. Now we'll create a class for our dashboard component, add an @component annotation to it, and start filling in the various parts of each. We need a selector so we can put something in our HTML which will cause this component to render. We'll add a template URL to refer to an HTML file with the MDL template page's body. But that file doesn't exist yet, so we have to create it, and we'll do that via cutting out the body of the existing template and putting it into the template file for our component. At this point, we can have a working page if only we add a few bits to our index.html and get our TypeScript code compiled. A styles URL array refers to a couple of CSS files we need for this component to render correctly. You should be aware that including script tags in your templates does not result in additional JavaScript files being loaded. I removed that earlier and put it into the dashboard component HTML, but it's not actually causing the MDL JavaScript to be loaded. So I'm adding that back to the index.html because we need it. If you click on the search or menu icons in the corner, you'll notice that neither is animating like it did on the original template page, and there's a reason for that. The MDL JavaScript only looks for those elements and sets up the animations if they exist in the HTML before the JavaScript runs. Since we don't render them until later with Angular, they don't get hooked up correctly. So we've hit another snag. Let's see how we can fix that. MDL provides a function we can call named upgrade DOM to wire up the menu, buttons, etc. if we added them too late to be picked up automatically. Angular provides lifecycle hooks on components where we can provide a function which will be called before or after certain things have happened. We'll use the one called ngAfterViewInit and add the MDL function called there. After we do that, our menus and button animations now work as expected. In this video, we took an existing site, quickly turned it into a component, tied CSS to the component, and tied into one of the lifecycle hooks Angular 2 makes available. Piece of cake, isn't it? In the next video, We'll start looking at a set of directives Angular gives you that you'll use over and over in building your own components. Stay hooked! In the previous video, we learned how to take an existing web page and turn it into a working Angular 2 component and use features of components to solve some problems we encountered. In this video, we are going to take a look at a set of directives Angular gives us for including, excluding, looping, and other really common things we will need to do when building our own directives. Then we'll use each one briefly to make it easier for you when you start to use it yourself. Back in video 1.5, you might have seen me use ng4 when I was rendering a list of users in the user list component. But it was blink and you'll miss it fast because I didn't want to dive into explaining that yet. But now it's time to start looking at the pieces Angular 2 provides to make it easier for us to write our components. We'll add core directives to the list of things we want to import from Angular and then indicate that we're using it on our component. Remember, when your component uses other components or directives, you normally have to list those on the directive. In Angular 2, dependencies like this are usually explicit. If we look at core directives in the Angular source, you'll see that it's just an array of directives, which is exported. We could import them one at a time, or we can import this one variable and get all of them at once. If you build any libraries of components or directives yourself, you could do the same thing if they're meant to be used or often used together. You'll notice that most of these are what Angular calls structural directives. They're used to conditionally include, exclude, repeat, or control our HTML. ng-class and ng-style are the odd ones because they're attribute directives, but they get used frequently and thus are included in the core directives. These are important, so let's put all of them to use individually to give you a better understanding of each one. We'll start by using ng4. An easy way to do that is to have a list of items we want to display in some way on our page, and this template already has a list of checkboxes down on the lower right-hand side there. Let's add some data we can use to power it to the class so that we can access it within the template. Now we'll remove the list items containing the checkboxes and add ng4 to iterate over the list in the class and turn it into one list item for each item in the array. For the moment, don't worry about the asterisk before the ng4. We'll come back to that in a later video. Just consider it required in the examples where I use it. The item is the name of the loop variable we're creating to loop over the array in our class. The loop variable could just as easily be any name, just pick something that makes sense for your code. Since the ng4 is on a list item, Angular creates a new list item for each item in the array. Inside that list item, you see that we can refer to the loop variable in the body to access the element we pulled out of the array. That's what ng4 does. It repeats the element you put it on and its children over and over again for each element of the collection you use it for. ngIf is equally straightforward. You might think of it as showing or hiding some HTML, but it actually does more than that. It actually adds or removes the HTML element on the page. Many times that's a subtle distinction. But if you're dealing with something really large, or which takes a long time to create, it can make a difference. We'll add an ngIf to the update card and the separator after it, and then add another variable to control it to our class. Changing the value of that variable, whether done via an API call or hitting a button, will now cause those cards to exist or not in our UI. Next up is ng-class. Before we cover it, I want to point out that Angular template syntax actually provides a really simple way to add or remove a single class. Just use code like this. If the expression resolves to true, the class will be added. If not, it will be removed. But if you want to be able to add or remove multiple classes, ng-class is a better choice. In this case, we'll use ng-class to change the color of the update card. I wanted to do something a little different in this example and call a function to remind you that the thing on the right-hand side in all these examples is an Angular expression. It does not have to simply be a single variable with a value like in the earlier examples. It can also involve functions being called and very basic code like comparisons. I wouldn't put complex code here in the HTML. You'll regret it if you do it. If you need something complicated, call a function on your class, like I did here, and you'll have some place to put code which isn't in the middle of your template. Note, ng style is very similar to this, and it gives us a way to add styles as needed to an element. Most of the time, you should be able to avoid applying individual styles to your HTML and use classes instead. So this is one that would be seldom used for me, but it does have its uses. ng-switch, ng-switch-when, and ng-switch-default are not strictly necessary. You could get the same effect with a series of ng-ifs within your HTML. However, you'd end up repeating a lot of text, comparing the same variables, etc. Just as a JavaScript switch statement provides an easier way to handle a common piece of coding, these do the same for our HTML and our templates. I won't belabor the point, but instead I'll just show a quick example of it in use. In this case, I've added a new value to the options in the class, and I'm using that as the expression for the ng-switch here. Then each ng-switch-when represents a different expression which will be compared against the switch value, and if they're the same, only that section will be included in the HTML. All others will be excluded. If none of the expressions evaluate to be equivalent, you can optionally include a ng-switch-default, and that section will appear instead. In this video, we have gone over each of the core directives Angular 2 gives you to help build your own components. You'll rely on them a lot, so we saw examples of how each one works. In the next video, we'll look at another bundle of directives. Angular makes a set of form directives available to help with validating, styling, and building your forms. In the previous video, we learned how to use a core set of directives Angular provides us for use in our components. In this video, we're going to take a look at another set of directives tailored to one of a web developer's most common tasks, forms. We'll see why you won't always need to use them, but if you do, how they differ from directives like ng-if or ng-class. We'll put them to use in a simple form, and then finally we'll look at a specific directive that's useful when you want to make use of a user's input as they type it. If you've been following along, you may have come to the conclusion that we can handle forms without needing any additional directives. For example, this form has an input and a submit button, and it works perfectly well. The reason it works is because Angular 2 has a template syntax that is very flexible, and in this case, it allows us to connect an event on the button to Angular code, map inputs to variables, and set values for those same inputs. But forms are used a lot and can be very complicated, so Angular 2 provides more than just template syntax to deal with them. To start, we'll import form directives into our file so that we can make use of it in a directive. If you thought core directives was a long list, form directives is a substitute for a much longer list. ng control name, ng control group, etc. as you can see here. I'm not going to go through all of these the way I did in the last video. Many of these get used automatically or will be seldom used by you. Instead, I'm going to focus on the form and ng control, ng model, and finally touch on the three validators. One of the things that's different from the previous directives we covered is that some of these directives have a selector that has the same name as a standard HTML element. For example, ng-form looks for form elements in our templates and automatically wires those up with some additional functionality. So form gets some new capabilities simply because we included form directives. Now we'll hook up the ng-submit event to trigger a function on our component, and we'll pass the form's value to that function. Right away, you should see that there's a difference from our earlier form. If we add an ng control equals some name to each control in the form will automatically gather up all the values for us. You saw that passed into our function up above. This is a very common pattern. You take lots of input and want the results when the user is done. As you can see, the form automatically gathered all the controls for us and returned it in a single structure. Now we'll add required to both controls and min length equals 8 to the password field. Just like our form was automatically enhanced by ng-form, required validator min-length validator, and several others are never added directly either. They look for spots where required or min-length were added to the controls. That's part of why I don't have to explain as many of the form directives. More than half of them are automatically added when we build a normal form or add regular HTML5 attributes to it. What the directives for the validators give us is automatic application of classes to our controls. When they're in error, a user changed its value, etc. They are ng-touched and ng-untouched, which tell you whether the user has interacted with the control. ng-pristine and ng-dirty, has the user changed the value of the control. And ng-valid and ng-invalid, which tells us whether the control is passing all its validations, like min-length are required. So then you can add CSS styling which only appears on a control if it's both invalid and has been touched, or controls with a required value, etc. All of that is pretty traditional form work and it will come in very handy. But another kind of form that comes up often is one where we want instant feedback and the user never submits. For example, a search field above a table. As we type, it instantly filters a list of items. To achieve that, we can make use of the ng-model directive. By combining the template syntax for events and attribute values together on ng-model, we can create something which instantly updates a value in our class, or which instantly updates the control if the class changes the value of the variable. And this doesn't even have to be inside a form to work. To demonstrate how this could be used, I threw together a quick little pipe to filter a list of people. As I type, the updated search term is automatically sent to the pipe, and the list changes as I type. We'll come back to how a pipe is created later, but here you can see how ng-model allows it to be fed up to the second data as it is entered. In this video, we have learned the directives Angular 2 provides us to more easily gather up the data from a form, get CSS classes automatically updated on our forms to reflect their state, and see how we can have two-way binding for real-time update of variables in our class as a user interacts with controls on the page. In the next video, we'll see how we can call a remote API in Angular 2, and we'll take a look at the idea of an observable and see how it differs from something you may already be familiar with, the promise. In the previous video, we looked at the different ways of handling forms in Angular 2. In this video, we're going to take a look at calling APIs, and especially at how you deal with the asynchronous things in JavaScript. Specifically, I'll talk briefly about JavaScript promises, why Angular 2 chose to focus on observables instead of promises, and then we'll return to an earlier example of calling a remote API with some new perspective. The first time a lot of JavaScript developers run headlong into the fact that it deals with asynchronous events differently is when they make a remote API call. Up to that point, they've probably used callback functions already for user events like onClick, but that seemed natural because no one knows when or if the event will happen. But when they make an API call, they often expect it to wait until the response comes back from the server, and their next line of code after the API call will only execute after that. And it doesn't. Instead, the next line of code happens immediately after the API call starts, and they're very confused at how to deal with that, or even why they have to. If all this sounds familiar to you and you already feel comfortable with asynchronous calls in JavaScript, or even better, you've already been using jQueries or AngularJS's promises, you're ready for the rest of this video. If, however, this all sounds new to you, or it's not an area where you're comfortable, you may want to do a little bit of reading before proceeding. Mozilla has a page where they explain promises in ES 2015, and there are a multitude of pages which attempt to explain in a variety of ways how JavaScript deals with asynchronous things. So let's assume you're ready, and you're already a fan of promises. They're great, and they've worked well for so long. But what if I tell you Angular 2 used RxJS observables instead of promises? The reason why is that promises were really only built to solve the situation where you have a single event which is either going to succeed or fail exactly one time. While that's true for a single API call, it doesn't model a lot of other kinds of events which we see every day in the code we write. Often what we have is not a single event which happens at some future point. We may have a whole sequence of events. Take for example a simple button. A user might press this once or 2,000 times. Likewise, WebSockets and timers are other examples of things we cannot model with a promise, but an observable handles easily. Even for an API call, we might find it useful to return a cached value first and then update when the server responded to our API call. And in fact, that's what we'll do just to get a small glance into the flexibility we get with observables. Because we want it to at least be possible for our return values to change, we'll try using a real API on the web which returns something other than mock data. For that purpose, I'm using Yahoo's Weather API, as they are nice enough to allow us to call their API without requiring API keys or user accounts. If you play with the examples given on this page and the Yahoo query language, you'll find it very easy to write a query that gets the data you want. In this case, I've got it pulling the local weather for Fort Worth, Texas, USA. If I make this call, I get a reply back with a temperature and a basic description of the conditions. To demonstrate this, I start with a service which basically does nothing. It returns an observable which doesn't perform any action. Then we're going to add in a small amount of code, which should look similar to what we did way back in section 1. It will make an HTTP query using the URL we got from Yahoo and return an observable for the results. We insert one extra step in between getting the results and passing them on by adding a map, which takes the value received from Yahoo and it digs down into it to return only the part we're most interested in. Briefly, we'll flip back over to the already built application component to see both how it is getting the data from our service, subscribing to it, and then assigning what it receives from the service to a variable it can display. At this point, we're just back to where we were before. But what if we wanted to return two values, an initial value, and then the value returned from Yahoo? To do that, I'll use a different observable from the one we get from HTTP GET. I'll create one and return it. And then I'll return a value right away using observer.next. Finally, I'll perform a call just like what we had before to hit Yahoo's API. And when that result comes back, I'll emit a second event for the same observer. Now, if you watch carefully, you'll see that it never displays NA for the date, temperature, or condition. Instead, it uses the first value returned and then updates when the current values arrive from Yahoo. AngularJS created and used its own promises library. Angular 2 could have stuck with promises or built their own observables library. Instead, they used RxJS. I think you'll come to find that it's a really neat choice. It's a powerful library with a lot of ability. In this video, we have looked at why Angular 2 chose to use observables instead of promises. Then we looked at a simple example of something different we can do with observables. In this section, we've taken a web page designed for an admin site and used Angular 2's core directives to turn it into a set of components. We've also taken some time to look into the directives provided to us to make forms easier as well and looked at observables. In the next section, we'll start to look into the most important part of Angular 2, the component, in much more detail than we have so far. Hello, welcome to section 4. Upgrading your components. In the previous section, we built some components with the core directives, tried out the form directives, and compared observables to promises. In this section, we'll cover the syntax Angular 2 gives us for building templates, give our components ways to talk to the world outside the component, create pipes, and understand routing. In the previous video, we learned how to use observables when we make API calls in our Angular 2 apps, and what they can do that promises cannot. In this video, we're going to look at Angular 2's template syntax in more depth. We'll look at how data from a component can automatically be inserted into our HTML, and how we can hook up class functions to events generated by both HTML and Angular components. Here's our page from earlier, where I've gone ahead and pulled out the various cards and made a component out of each one. I'll make use of this as I demonstrate some of the template syntax Angular 2 provides. First off, either print out or make a link to this page. It provides you with a quick reference for Angular's template syntax and lots of other info you'll use frequently in your coding work. The whole point of the sophistication of the Angular 2 template language is to make it possible to use existing controls without having to create components just to wrap each one. With that in mind, let's look at what we can do in our templates. By putting square brackets around attributes of our elements, we can equate them to an Angular expression and assign values or call functions which return values. Adding a pound sign, or hashtag if you're more used to that name, in a variable name gives us a way to create a reference to a particular element we can use in the rest of our template. This is two-way binding, and we saw it before when we were looking at the form directives. It allows us to update a control with new values when we change them in our class, and update the values in the class as they are changed within the control. If you only have one CSS class you want to turn on or off for an element, the template syntax provides a great shortcut you see here to do so. Likewise, if you just want to set one CSS value, then there's a shortcut for that as well. If you have more than one class or style to adjust, be sure to use ng-class or ng-style instead. Shortcut or not, to repeat this several times on the same element is going to be a mess. This is probably one of the most common types of template syntax you'll see in Angular 2, or even in many other frameworks. It's often called mustache syntax because of the resemblance of curly braces and mustaches. It basically says, look up the value referred to inside the braces and put that value in this spot in the template. When a pipe is specified, the value retrieved is passed through the pipe before it is inserted. Finally, there's an operator which goes with our Angular expressions with a bizarre name. The Elvis operator, $period, can be used in our variable dereferencing, where we use dots today to indicate to Angular that we're not 100% sure the first part of this will evaluate to a valid object. It might be null. So anytime you find yourself unsure about that in your template code, put in the question mark before your dot, and Angular won't throw an error if it runs into a null at that point in your JSON data. Note, as useful as the cheat sheet is, as much as we have and will go over all the template syntax in this course, there's actually no substitute for the full article covering the syntax on the Angular I/O site. Once you feel comfortable with the basics, go read the developer guide to fill in any gaps in what you know about it. In this video, we have gone over most of the template syntax you're likely to use every day as you develop components with Angular 2. In the next video, we'll look at how we can make components which can take data in from the outside and send events to be used by other components. In the previous video, we learned the extensions to HTML which Angular 2 provides as part of their templates. In this video, we're going to take a look at how the @input and @output decorators allow us to create components which can have data flow in and events flow out. In addition, we'll look at how a component which encloses other components and HTML can make use of that wrapped material in its template. If you look at the elements built into a browser, you'll notice that many of them have certain characteristics. An example is a button element. A button has properties which may be set and has events it emits. In Angular 2, we may create components just like this. We can create reusable pieces which display something, which our users interact with in some way, or which do both. And as far as our HTML code is concerned, they may be made to look indistinguishable from the elements like button, image, etc. An input is our chance to pass data into our component from an external context, like the template from another component. This is really important, and I want you to pay attention to this, in particular how you should think about structuring your components. Do components in HTML know about the data they're going to contain? Do they go obtain it themselves? In general, the answer to that is no, and that is part of what makes them highly reusable. If you want to build highly reusable components for your work, ones which are easy to test and reliable, then you should pass data into most of your inner components. They typically should not be pulling data down themselves, nor should they be using service classes to do so. Instead, you can pass into each one the data it needs, and it may in turn pass some subset of that data down to the components it uses in its template. By doing so, only the outermost root component will be smart, and all the inner components will be dumb, but hopefully easier to build and test and much more reusable. There was a reason I wanted to talk about RxJS previously, and it wasn't just because it was used by Angular's HTTP API. It was because it comes up again here when we're creating a component which has output events. We may need to trigger those events many times, and thus a promise never would have done the job. Instead, Angular has used an observable to create a class called event emitter, which we will use whenever we want to emit an event for anyone using our component to receive. If you think back to the template syntax we studied in the last video, you'll remember that we can put parentheses around an event and then use that to call a function on the class and component. This is where we will trigger those events and provide event data so other code can hook code to our component's events. This gives us a chance to signal events just like buttons, inputs, etc. do in regular HTML. We'll create two outputs on our component and tie them to event emitters. One event will trigger when the user enters the right username and password, hard-coded in this example, into the dialog, and the other event will trigger if the user gives the wrong username and password. Now if we use this component from within another component, then we can use the template syntax to add functions which will be called when the events fire. In this case, we'll do something within the outer component to react when the events fire. But you can easily imagine that the outer component might take actions in response to the inner component events, and perhaps fire events itself. Another component, which in turn used that component, would use its inputs and outputs and perhaps never even be aware that it wrapped other components to do its job. Finally, I'll wrap up this discussion of inputs and outputs by noting that you don't have to have exactly the same name for your inputs and outputs inside your component and outside. Angular allows for that with the @input and @output by putting a string for the external name here inside the parentheses after the decorator. If you do that, you'll still use the actual variable name inside your code, but the other name will be for those who use the component. Before I wrap up this video, I want to talk about one more thing you're likely to want to do at some point, and that's create a component which you use to wrap other directives and/or HTML. For example, what if you want to create a component which formats or contains whatever you put inside it? Normally, whatever you put inside your directive is simply discarded by the Angular compiler when it inserts your template into the DOM. But if you want to make use of what was inside your component tags, you can use ng content inside your template, and Angular will know where to insert that material for your template. In this video, we have looked at using inputs and outputs on our components to provide us with the ability to pass in data and trigger events. We also saw how we can create components which can be used to wrap other components or HTML. In the next video, we'll see some aspects to templates you might not need often, but you will likely need eventually, and talk about the pipes Angular provides, as well as creating our own. In the previous video, we looked at how to make components with inputs, output events, and more to make them really useful. In this video, we're going to take a look at how to deal with ngIf and ngFor with repeating elements without a wrapping element. Then we're going to take a quick look at pipes Angular provides and how you can build a custom pipe to get exactly the filtering or translation you need. You may recall from the discussion of template syntax that I used both ngIf and ngFor with a star in front of the directive name, but I didn't go into detail about what that meant. It's actually very straightforward what it means. It says that the element that the directive is on is the template we want to include or remove in the case of ngIf, or repeat in the case of ngFor. If it's a div, for example, then it and everything inside it will be the template and will be repeated or included, etc. But in my experience, you will hit circumstances where you want to repeat multiple elements without a wrapping element. AngularJS version 1 used two directives named ngRepeatStart and ngRepeatEnd to mark the beginning and end of a repeating section. But Angular 2 has no equivalent for that yet. There's still a way to do it though, and it's not that difficult. It comes from what the star actually does. It creates a template and then applies the ngFor to that template. You can do the same yourself, and the benefit is that the template doesn't get inserted into the final HTML, only its contents do. Angular actually has a whole section of their guide to template syntax devoted to star and template and how the two relate. For a quick example, I'll show what happens if we wanted to repeat definitions in an HTML definition list. Normally, there's a series of term and definition combos within a definition list, and there's no wrapping elements for them. To do it, we'll create a definition list with a DL and put a DT and DD inside it. Since we want that set to repeat, we'll put them inside a template and then translate the star ng4 we used before into what Angular wants when we use it on a template instead. To me, that syntax is pretty strange if you're used to the most common usage of ng4. I doubt I'll be committing it to memory, so I can just rattle it off. However, the Angular docs have made it easy to look up for those times when you do need it. The latter was just a nuance I wanted to cover before we moved on from components and template syntax. Pipes, on the other hand, will be very commonly used as you build your templates. In the video where we discussed forms, you saw me briefly put a pipe to use to filter a list of items as I typed, but it wasn't really explained what a pipe is, nor how it was built. Angular 2 comes with a variety of pipes available for you to use right out of the box. Here are a few of them to show how they are used. Even though Angular does not include a huge number of them, you can count on hundreds more appearing in short order as people create the ones they need, and they wrap libraries like Lodash or Moment.js to filter arrays of objects or format time values in specific ways. But if you look and cannot find an off-the-shelf pipe to do what you need, you can create your own very easily. To demonstrate, I'll recreate the one I used previously for filtering a list of items. First, create a basic search.pipe.ts and inside it import pipe just as we imported component before. Create and export a class named basic search pipe. Add @pipe with name basic search decoration to the class. Add a transform function which takes in a value. If you just returned the value as is, you would have a no-op pipe which did nothing. For the search pipe we used earlier, we were passing in an array as the value, but in addition, we needed to pass in a search term as well. Any parameters added after a pipe are passed in as additional parameters to the transform function. The rest of the code, basically just one line in the transform, is a filter call which lowercases the incoming text and compares it to each item in the list, returning only those which match. Admittedly, that was a super simple transform function. It filtered our array with only one line of code. Imagine what you could do with even a little more code. In this video, we have learned a workaround for certain template needs and about the pipes Angular provides and how we can create our own. In the next video, we'll start learning about using routing in Angular to work with our views. In the previous video, we learned how to create your own pipe and how to deal with repeating a sequence of elements in your HTML templates without having to wrap the output with another element. In this video, we're going to take a look at linking URL changes to changes in our UI via Angular 2's routing, creating links to switch between routes, having a route which is used both with and without parameters, and having a default route. When you're building an application which has multiple views within a single page, often called a single page app, using the current URL to trigger the changes between views works particularly well. Users already expect their URLs to change as they navigate through an application. They also like to be able to save bookmarks, copy and send locations to friends and colleagues, or use the browser history functions to move back and forth through their history. In other words, they expect apps, even if built with new frameworks and very different technology, to still work the way websites traditionally have. Fortunately, the Angular 2 framework provides full support for that. Let's see how that works by starting with this app component at the root of our application. What we would like it to do is support a couple of different views between which it switches as links are clicked or when we tell it to do so from within our code. The core of this app should look familiar, as it's the same as what we had back in video 1.6. The only difference is that I've stripped out the mock version of the user service from this one and added another view, which retrieves the information for just one user and displays it. First, we have to define the spot within the app component where we want the child components inserted when the routes match. We do that by putting a router outlet in that location, but as we've seen many times, you can't just go inserting new directives anywhere without first importing them into your code and your components. So we'll import several things we'll need from the Angular 2 router and then add router directives to the directives used in our app component. Now we need to do some simple configuration. We'll add an app.router.ts and put a series of route definitions into an array in there. Each one is a mapping from a particular route to the component we want created at that route. The first such route gives us our list of users. The second route is the one we'll visit to view a single user. As you might expect, we have to import both of the components in here we use in the routes. This first route is very straightforward. It simply says that when a certain path is seen, it corresponds to the user list being created and inserted into the spot where we put the router outlet earlier. The second adds a small twist. It's just like the previous one, except that it has a parameter in it. That says that whatever value is in that spot marked with :ID will be picked up and sent to the component when it's created via the route parameters. We haven't seen those yet, but we will momentarily. That's because at the moment you'll notice that the subcomponents we're using don't have anything on them yet that ties them to routing at all. They're just regular components, and if we didn't need any route parameters, they could stay exactly as they are. That's it. At this point, you actually have Angular 2 routing working. It may not be super obvious because we would have to actually change the URL manually in order to see it switch. So let's add a link to our user list to see the user view for each user. We'll use another router directive named router link to do that. In order to get that parameter in our people component, we need to add an activated route as an import and then add a constructor which injects it into the class. Having done that, we could use the value to look up the user details from our service. I've already added a function in the user service to get some fake data per user from recres.in, the same way we get the pages of users from another API call they offer. Note that both our routes are exactly the same. They differ only in the parameter which may or may not be there. Yet Angular's router is perfectly happy differentiating them based on just that small difference. There is a problem here though. We've gotten by so far by entering /people in as our starting point manually. What if someone just types the domain name with no following path? Well, they'll get an error. None of our paths match that situation, so the page won't work. Let's add a default path to fix that. We'll add another route definition at the end of our list which picks up any other route not defined above it. The ** matches everything, and the redirect to tells it to redirect the user's browser to our default path. Now we can arrive without any route at all and still end up where we need to be to start our app. Another thing which might not be immediately obvious is that none of the components we're inserting via routes need to have selectors. Since you're actually having them created and inserted by class name, you can get by without selectors on these components. However, you may still end up wanting to have a selector on the components anyway for reuse or testing purposes. In this video, we have started to take advantage of Angular's ability to connect routes directly to changes in our UI. In the next video, we'll go into more depth on routing by looking at changing routes with code, processing attempts to enter or leave routes, and some details about our URLs. Welcome to Advanced Routing, our second video devoted to the routing system built into Angular 2. In the previous video, we looked at setting up a simple set of routes which adjust our UI automatically and how Angular helps us create links to perform those switches easily. In this video, we're going to take a look at how we can change our routes programmatically, control entry and exit from our routes, and different ways of expressing routes in our URLs, and how they affect server-side code. Sometimes a user will take an action, and you may want to include a route change as part of that action. For example, the user might delete an email, and then after the deletion occurs, you want to reroute back to the list of all remaining emails. To see that programmatic route change in action, we'll add a click action to our links and drop the router links we used in the last video. We can trigger that same navigation within a function on our component. First, we need to have access to the router, so we'll inject it into the constructor for our component. Now that we've got the router available to us to use in our class, we can simply call this.router.navigate and pass it the same link parameters we would use to create a router link. Despite switching out our method for triggering the router change, it still works exactly as it did before. There's a good chance that another thing you're going to need to know how to do at some point is control a user's ability to go to a route or leave their current route. That's made very easy for us to do by specifying either can activate or can deactivate on a given route. For example, we can try and control a user's ability to go to certain routes. We'll add a can activate parameter to the path we use to view an individual user. This is an array because you can have multiple guards on the same route. We just have one here. The guard class must be imported, and it has to be added to the list of providers so that it can be found in the dependency injector when needed. The class itself is ridiculously simple. It implements a canActivate function, which returns true if the user can go to the given route or false if they cannot. Since it's currently returning true, we can click the links on the user list and view the individual pages for users. But if we edit the guard to start returning false from the function, we can't go to the people page anymore. The function itself can do anything, which returns an immediate Boolean value, like we did in our example, or return a promise, which resolves to a Boolean value. That makes it easy to do something like call an API to find out if a user is authenticated. Finally, we have to deal with something I think is significant with regard to routing, and that's the difference between the old and new styles of routing in Angular apps. Bear with me for a moment here because this may seem esoteric, but you need to understand this because it affects how you write your app and whether you need to do anything special to set up your server for the app. What you saw in the last video was the new way, whether you realized it or not. We had to specify a base URL in our HTML, and the routes we created were added directly to the end of our existing path in the browser. There's a ramification of doing it that way that you need to understand. What if I save this URL as a bookmark or send it to a friend? When the browser asks for this URL from the server tries to take every bit of the URL from start to end to try and find a directory and a file to return to the browser. That means it's looking at parts of the URL we had intended only for the Angular router and expecting them to translate to a file path. In other words, unless we configure our server to expect that and just deliver the index.html anyway, this will just get us a 404 file not found when we ask the server for it. Now, configuring Apache, Java, Nginx, or whatever you use for a server isn't that hard if you're comfortable doing that and you have control over the server. But if that's not practical for you, or you don't want to make changes to your server setup for that kind of routing, you can tell Angular to use the old way of handling routes instead. For the old way, the HTML page is always going to be referred to exactly the same way in the URL. It'll always be index.html. It's what the user will actually ask to download. The route is instead stored as a hash on the end of the URL. It does not look as nice. It doesn't look exactly like a regular URL. But it does work, and it requires no special server configuration. Here's an example of that kind of routing in one of my older applications. If you want to switch to the older strategy for routes, then you need to switch Angular's way of doing it. They use an object known as a location strategy to govern how they write their links and read their links. Angular 2's default strategy is the way you've already seen. If you want to switch to the older way of dealing with URLs, you do that when you're bootstrapping the application. Previously, we added router providers to the dependency injection system when we bootstrapped the application. Now we'll add a line after that to override the location strategy, and we're done. Now, all of our links use hashes, and we can still navigate to pages just as before. In this video, we've taken routing from a discovery level to what I think is an actually useful level. You can trigger route changes on demand from within your code, control access to certain routes, and you've seen how to switch URLs with hashes so you can avoid server configuration changes. In this section, we have covered core and form directives Angular provides us, looked into observables and how they are used instead of promises in HTTP code and elsewhere, seen the template syntax components use, how to add inputs and events to our components, and use Angular's routing capabilities to update our UI as our URLs change. In the next section, we'll look at how to structure a large application built using Angular and try to answer the questions about what role the front and back ends have in that kind of app. Look at how to communicate errors from the back end to the front end and tackle the super important topic of security in your app. Hello, welcome to section 5, Building It Bigger. In the previous section, we looked at Angular 2 template syntax, observables, and routing. In this section, we will cover structuring a large single-page application, how to handle the inevitable errors when talking to a remote API, and making a secure app. In the previous video, we looked at some advanced parts of the routing system. In this video, we're going to take a look at things you should think of when building out a single-page application, or SPA. Specifically, splitting your app into completely separate front and back ends, thinking about your routes, and avoiding areas where JavaScript-based apps need help. Having now built several applications using Backbone.js and AngularJS, I have rules of thumb and questions I like to think about when I'm trying to figure out how to structure my apps. First up is the simplest and most straightforward rule. Divide your app in a hard line between the code which runs in the browser and that which runs in the back end. The back end is an API, a series of URLs with which the front end communicates. It can be written in most any language as long as you can send JSON data to it, receive JSON data back from it, and it can run business logic, which does not belong on the front end. If you do this, you'll end up with a functional UI built entirely using HTML, CSS, and JavaScript. There are many big benefits of doing it this way. Among them are that prototyping can be faster, debugging more straightforward, and testing easier. We'll be returning to the debugging and testing aspects of that in later videos. But there are other potential benefits as well, such as improved speed via caching of the CSS and JavaScript in the browser, simpler logic on the server and client sides, and less demand on the servers due to a client that needs to make fewer requests. Also, since the files are not changed on the fly, they work well on content delivery networks, CDNs, for faster delivery around the world, and they're easy to serve up via simple arrangements using Apache or Nginx web servers. If you're unsure of where to start for the backend, use a site like Programmable Web to find examples of APIs which might be like what you need, and see if you can learn from them. Next up, if you're still at the beginning of your project, it's a good time to think about the following questions. How will I deal with browser bookmarks, browser history, and shared bookmarks? And am I actually going to build my entire app as one single page? First, bookmarks and tabs. Plan your routes. It's as simple as that. Every time you build a set of your functionality, think about where and when users may want to bookmark things, and what data would have to be in the URL to get them back there. A corollary to that, which is often ignored, is opening multiple tabs on the same application. I regularly click on links within the browser and open them in new tabs. That allows me to keep my current place while exploring where a link goes. If you have good links, then each tab will have enough information to be able to launch independently and work independently. Second, is your entire app going to be a SPA? Just because the name is single page doesn't mean that that's a one-size-fits-all solution for every app. If the user only ever loads one HTML page and stays there forever, you may find memory management can become tricky, and you need to be careful not to create a lot of data and hidden UI which slows down your user. For some apps, SPA is great, but even Google chose to split Gmail's settings off into a separate app from the main page for a long time. Since then, they've merged it back in. But if yours is a large application, you can probably find points at which you can split your app into multiple sub-apps and move back and forth between them in order to reduce the complexity. Now we should talk about times when an SPA is not the best solution, or at least you need to know that there can be some problems you may have to address. The biggest problem you're likely to encounter is search engines. In the old days, pages were usually generated by a server, and search engines could just download the HTML and largely ignore the CSS and JavaScript which came with the page. But for a page which uses JavaScript to render most of the text, if the search engine ignores the JavaScript, the page will probably appear largely blank. If you're building software as a service, that might not be a big deal, but e-commerce, news, entertainment, and many other kinds of sites live or die by their search engine placement. This is less of a big deal than it used to be, because Google now retrieves web pages and runs the JavaScript too, so it sees the same page your users see. But many other search engines may not do that. If you're having problems with search engines, then there are third-party services like Pre-Render or Brombone, which help you serve up your pages with the JavaScript already executed when search engines show up and ask for pages. In this video, we have gone over the advantages of building an SPA, where the front end is responsible for virtually all the user interface, and the back end handles only data and business logic. We've also talked about a few cases where you might deviate from that. In the next video, we'll talk about how to handle errors which happen when talking to your remote API. In the previous video, we learned how to structure a single-page application and questions we need to address when building one. In this video, we are going to take a look at handling the inevitable errors which are going to crop up when we talk to remote APIs. We'll look at identifying real HTTP errors, differentiating API errors, and dealing with authentication errors. In my experience, there are three distinct kinds of errors the front-end developer has to deal with. There are actual HTTP protocol errors which you receive. Then there are errors which can occur when you call API calls. And finally, I reserve a category all for itself for authentication errors because they are so common. The simplest kind of error are those where there was a failure in the HTTP protocol. If you ask for a file which the server cannot find, you'll get a 404. If the server has an error while trying to satisfy a request, you might see a 500 error. These are common errors, and for many of them, you cannot even directly address the cause of the error with anything you do. But when we're talking about APIs, many use these same response codes to try and communicate API errors back to the caller. Twitter actually has a list of 14 different response codes you might get back. On top of that, with many of them, you also get JSON data to clarify what the code is trying to tell you. On an application I was developing, testers told me their calls were not working. I investigated and found 404 errors on API calls I made. When I passed it on to back-end developers to fix, I was told, yes, we're returning 404 now if you're not authenticated. So I was left unable to tell a missing URL from an expired session. I would argue that Twitter does not need 14 different codes, and that we should not have been using 404 errors for a completely different purpose. It's just confusing. Pick a few response codes that actually mean something. We now use 401, unauthorized, as our only meaningful code. For all our other API responses, we actually get them back as a 200 success. So if you're not going to use HTTP error codes for all of your various errors, what would you do instead? I can only tell you what has worked well for me. but I like to use jsend to wrap all API returns. It's nothing more than a small JSON wrapper with a status code indicating success, fail, or error, and the same data you would have sent back normally. In addition, if there's an error, you'll get back an error code, an error message in the wrapper as well. It's simple, and you can write code into your app which watches every return and picks out the errors and handles them all uniformly. In order to demonstrate how easy it can be to handle both kinds of errors in an Angular 2 application, I've put together a really quick example server and client. The server should return a list of crayon colors with both a name and a hex color for each one, but it will actually cycle between returning the list as it should, returning a 401 unauthorized error via an HTTP error code, jsend fail, and jsend error with an error message. Let's start up the server using node errorserver.js and look at a simple client app which displays all the colors if the server actually returns them, but at present doesn't handle any errors at all. How much would need to be changed about the API call, and is there some reusable code here which could handle these errors in a consistent way? The answer is this little, and you could easily wrap the HTTP class with code to handle all of this automatically, so you wouldn't even have to remember to do this minimal amount. We'll import the two error handlers, one of which handles the HTTP error codes, and the other of which automatically handles the JSend and unwraps the response. I've already written both of these, but the code for a simple implementation of both is easy to understand. I used the humane.js library to provide me with an easy way to display errors to the user, and the JSend handler makes use of it to display any message returned from the backend API, or to display a failure, which usually means a programming mistake. The catch handler just identifies the type of HTTP error code, and I took the opportunity to pop up an alert to simulate where you might re-authenticate the user. You could forward the user to a login page at this point, or even use a pop-up login dialog to authenticate in place and leave the user ready to retry whatever operation he or she just tried. In this video, we have talked about how the backend and front end can best communicate errors. Excellent! In the next video, we'll talk about securing your application. In our last video, we covered how to handle errors in our application. In this video, we're going to take a look at learning that browser security isn't, prioritizing server security above all else, and why doing business logic in the browser is usually a mistake. I'm going to go ahead and spoil the surprise here and tell you the most important part of this video right up front, so listen carefully. Anything you do in the browser for security is not secure. Live by that message and pass it on to everyone with whom you work. You can prevent a user from clicking on a button or a link by disabling or hiding it. You can get data from the back end which you choose not to display to the user because he or she doesn't have the right permissions. But in any of these cases, the user can easily open the debugger for the browser and re-enable the button, can see all the data shipped to the front end, and can pick apart your code and watch the communications between your app and the back end to know what API calls to make. Here we see just such an application where we're able to see our own account balance, but not that of another account. And the delete button is disabled on their account too. It might seem secure, but it's not. Our API calls aren't magical. They're simply URLs, which anyone can request from the browser to get the data. Most users with even a modest amount of knowledge can figure out how to make your API calls and try out different parameter values to see if they can see another user's data or do something they can't do in your user interface. If we bring up the Chrome Developer Tools, we can refresh the page and see that the balance may not be displayed on the page, but it's right there in the data sent to the front end. And I can re-enable the button and delete another account. Plus, if I use a tool like Postman, I can just use the same API URLs the app uses, but cut out the middleman of all that local security. Now I'm able to do anything the API will let me do. I say all of this not to say that there is something inherently wrong with single-page apps and APIs as a way to build applications. There isn't. It's actually a great way to build apps. But you absolutely must lock down your APIs at the back end for it to work. Validate every parameter of every function call. Make sure that no user may make an API call which he or she should not be allowed to make, and that no call returns data that any user should not see or allows any user to change data that he or she should not be allowed to change. Build a really solid API with every call well secured, and you will never have a security crisis in your app. Sure, someone may mess up on the front end and enable a button they shouldn't, or try to show some data the user shouldn't see. But when they click that button, they will get an error because the back end made sure they couldn't perform the action. The data won't show because the API made sure it was never sent to the browser. Users may be annoyed by a bug like that in the UI, but there will be no security breach. In this example, if we make all the same calls to our version 2 API with security at the API level, I can't get balances I'm not supposed to, and I can't delete anything I'm not supposed to. The API stops me, and what the UI does for security is just there to improve the user experience by showing the user what can and can't be done. If you don't do this, don't be surprised at the level of hacking you find yourself experiencing. Some users will never try anything. Others will figure out everything you did wrong and take advantage of all of it. Now there's a corollary to what I just said that has to do with business logic. Don't try to sequence multi-step operations from a series of API calls from the client side. Ignoring someone who skips a step, repeats a step, or alters the data sent for a step to try to gain some advantage, most of the users who blow you up on this can be doing it for completely innocent reasons, which have nothing to do with security. Let's say I have to perform a series of actions every time someone changes their name, perhaps due to marriage or divorce. If I let the front end drive this series of actions and the user closes their laptop midway through the sequence or their browser crashes, then what? Is my database left in a corrupted state? This can be another big problem in your API. Never create an API that is finely grained for the front end to use. If you're doing something which involves several steps and they must always happen together, make sure the front end gathers all the data needed for all the steps and sends it in one request so the server can sequence everything and do so with transactions and other precautions to prevent data corruption or exploitation. In this video, we have hopefully learned the cardinal rule of client-side security. There is none. Also, we've talked a little bit about why you should never rely on client-side code to sequence multi-step operations on the server. In this section, we've talked structuring your whole app, front to back, about how to deal with API errors, both what gets sent and how we handle it on the front end, and seen some things that absolutely must be done at the API level to give us any security. In the next section, we'll look at how you can debug to find problems and create unit tests to automatically let you know when you've broken something. Hello and welcome to Testing and Fixing Your Work. In this section, we will look at how to debug the problems you will have as you build your code, how to test parts of your code, and how to know how much of your code is covered by unit tests. In the first video for this section, we'll talk about debugging. Inevitably, as you write code, you'll write bugs too. You've got to learn some techniques to save you time and save you grief when the inevitable happens. In this video, we're going to take a look at using Chrome's developer tools to help you debug, a debugging tool designed just for Angular 2 apps, and see some resources for learning how to use the developer tools better. I mentioned previously that I think debugging is particularly nice in an application built with a JavaScript front end because there's a nice clean line of demarcation between the front and back ends, which makes finding certain types of bugs easy. For example, you expect to see dates for all of these movies, but you don't. Is that because the API response did not include them, the JSON was incorrectly formed, or is the front end not rendering them properly? Answering that question is as simple as bringing up the Chrome developer tools and clicking on the Network tab. There are many ways to bring up the developer tools, but two which you should get used to because you'll use them most often. The first is to right-click on a particular element on the page and pick Inspect from the menu which pops up. The other is to use the shortcut key to bring up the Chrome developer tools. On a Mac, that's Option-Command-I. But if you're on Windows or you just don't remember the shortcut key, you can find it right here on the View menu, Developer, Developer Tools. Then select the Network tab and filter to only the XHR calls. That's where all your AJAX API calls will appear, and you should be able to quickly find the call in question and see both the API call you made and any data which was sent with it, if it was a post, put, etc., as well as what was sent from the server to you. In this case, we can see that the API call never returned the data we hoped to show. But not every bug will be somebody else's fault. When it's due to front-end bugs, you need to turn to the other parts of the developer tools. Teaching you even the basics of the Chrome developer tools is way outside the scope of this course, because I'm pretty sure I could devote an hour to that topic alone. However, I do want to do two things. One is emphasize just how important it is that you get really good with this debugger. Literally, every minute you spend learning to use it better will pay you back later with 5 minutes less time trying to track down a bug. And then I want to provide you with a couple of good resources you can actually use to do that learning. The first is Chrome's own webpage devoted to their developer tools. There you can learn about some of the many things it can do for you, like breaking the developer tool off into a separate window so you can see all your work, setting breakpoints, watching specific variables, simulating slower communications or specific device screens, and the list goes on and on. The second is Umar Hansa's great developer tips site. Chrome is constantly making changes and improvements to the developer tools, and if you don't know they added something, you can't very well use it, can you? So Umar sends out a great newsletter in which he includes GIF images which demonstrate new features and sometimes old ones you might have forgotten about. Trust me, there's something about seeing somebody use a feature that helps you remember later that it's available. It probably seems like I'm unfairly mentioning only the Chrome developer tools, when there are also developer tools built into Firefox, Safari, Internet Explorer, and even add-on tools like Firebug, which works with Firefox. Part of the reason is that at the time of my writing this, there is an Angular 2 specific tool which is available only on Chrome called Augury. It gives you insight into your tree of components and can help you with your debugging. If we flip back to one of our previous examples and look at it again with Augury installed, we see that there is another tab inside the Chrome developer tool for it, and we can use that tab to see the components on the page, their properties, state, etc. to help you with your debugging. In this video, we've looked at debugging an Angular 2 application, specifically where to look for possible data errors, how to make use of Chrome developer tools, and especially where to go for more information on how to use them better. In the next video, we will dive into creating unit tests for our code. That will give us a safety net for when we make changes and fix bugs. In the previous video, we learned how to figure out whether certain problems are happening in our Angular code or in the remote API, and how to get better with the browser development tools. In this video, we're going to take a look at both Jasmine and Karma, tools we need to write our unit tests and then run them. Then we will create needed configuration and a couple of simple tests to try out what we've learned. If you're going to create unit tests for JavaScript, there are several different frameworks you can use to write them. AngularJS used Jasmine as their official framework, and Angular 2 uses the same one. Jasmine provides a framework for writing single tests and for grouping sets of tests together with descriptions and functions you want to run before and or after each test. Part of that framework I mentioned is about being able to test various conditions during a test and fail the test if they don't pass. In addition, it provides code to simulate certain situations like the passage of time or remote calls to another server, and to allow us to easily make fake objects known as mock objects, which can be used to help us make our tests work. If we use Jasmine to help us write our tests, and we add our code that we want to test, we've got all the code we need to run. But there has to be some kind of JavaScript engine to run the code and the tests. That's where Karma enters the picture. It loads all our source code, unit tests, and libraries up in a browser, like Chrome or Firefox, and then runs the tests and makes a note of which test succeeded and which failed. Often, we don't want to fire up a browser to run our tests, so we use a special browser called Phantom.js instead. It's a browser which code thinks is a normal browser, but it never puts up a window on the screen, and it never interacts with the user. It just provides a place for us to run our tests. We'll set up our testing environment using Karma and Phantom.js, and doing that will make all of this a whole lot clearer for you. The first thing we'll do is use the Node.js package manager npm to install Jasmine, Karma, and some other pieces we're going to need. We've already got those installed as part of our regular set of packages. The only parts that might not be clear right now are Karma coverage and remap Istanbul. Don't worry about them. They'll be explained well in the next video. The next part we need is a shim that will make sure that Karma can load our source code, which depends upon System.js, to emulate the ES 2015 module loading. I want to apologize in advance for this code because it's magical, and I hate magical code that I don't understand well myself and which I did not write. But this shim is based upon one from the Angular team, and it's necessary for Karma to be able to load our tests and the code which they load. So I think you'll need to grit your teeth and copy this one pretty much as is from my project for your own use. Part of what it does is set up Karma for testing Angular 2, help Karma know which of our files are testing files and which are part of our code, and it helps with paths to various libraries we use. We must also have some configuration for Karma to know what to load and how to run what it loads. Despite what looks like a lengthy file here, there are only about 40 lines worth of actual configuration here. The rest is just comments explaining the configuration and lines with closing brackets. The file section is extremely straightforward. It simply points to our source code and the libraries on which it depends. Jasmine gets specified as our test framework on a line just a little bit lower than that, so we don't have to include that library in this list. Most of the rest of the file just specifies a list of Karma plugins we need for various reasons, and that we don't just want to see the results of running the tests. A digital record of which one succeeded and failed should be written out to a JSON file. We'll come back to that in the next video. If we now update the gulp file.js so we can run our tests from Gulp, we'll be ready to write a couple of tests. Doing that is pretty straightforward because Karma can be incorporated directly into Gulp. As you can see here, I just pulled the npm Karma package directly. Once we've got that, we can add a new Gulp task, which will allow us to run our unit tests. At this point, we can now run Gulp Karma to run our unit tests. But we don't have any unit tests, so let's write a couple of simple ones and make sure this works. Hopefully at this point we can finally put the last of the magic to bed and actually see a couple of tests. I'll make them super simple and guaranteed to pass just so we can see this work properly. We will add a describe function which wraps our tests and give a name to the group. Then we'll write two quick tests inside the describe function. The first test will test that true is indeed true, and the second test will confirm that null is not the same thing as undefined. These tests are just simple tests of JavaScript code and are using the most basic parts of Jasmine to validate some insertions. Nevertheless, we finally have some unit tests that we can run and confirm that we've correctly set up our testing environment. In this video, we've gone over the tools we use to build unit tests and then run them. Then we made sure we had everything set up correctly by creating a couple of very simple tests. In the next video, we'll look at how we can do unit testing specific to Angular 2 and how to know how well our unit tests are exercising our code. In the previous video, we looked at how to get set up to run unit tests for JavaScript code and actually created a couple of simple tests to run. In this video, we're going to build upon that to create some tests for an Angular 2 component. Then we're going to help you answer a question anyone with a lot of tests and a lot of source code has. What have I really tested? In the last video, we set up to do Angular 2 testing, but the only tests actually written were really simple JavaScript ones, which should never fail. Now we need to graduate to doing real AngularJS testing, and we'll start that with this component I built ahead of time. It's equivalent to some of the introductory tutorial for the graphic library d3.js, specifically the tutorial called Let's Make a Bar Chart. To do that, we'll make use of an Angular 2 extension to Jasmine called Before Each Providers. Jasmine already provides functions like before each and after each, which you can use to hold common code which will be run before and after each test in a series of tests. Before each providers is similar, and as you can see in this example, it allows us to specify what we want injected into our tests. The bar chart component is our own code, and the test component builder is more code to help us with our unit tests provided by the Angular 2 framework. Here's a really simple example of that where we're injecting the component into a test and then writing an expectation that we got a component rather than just undefined. That's a pretty basic test though. We need more than that in order to get a lot of good out of our unit tests. This is the next level of that kind of test. Now we're doing more than just injecting a component. We're using Angular's unit test helper async and injecting the test component builder. Once we've got it, we use it to create an instance of the bar chart component and look to see how it changes from when it is first rendered to how it looks after we've called the ngOnInit function we created to render the chart within d3.js. In this case, we're not putting any data into the control, so we expect it to look exactly the same both before and after ngOnInit gets called. The result is that SVG gets rendered inside our component. You can select and get right down to the details on matching exactly what you think that SVG should look like, but that often can result in a more fragile unit test than if you just test a handful of basic things. This test confirms that we at least ended up with 2 new graphical elements and that 2 new pieces of text are in the SVG, and it leaves it at that. Now, even if d3.js changes its library a little, it's not likely to break my test like it would have if I tested for exactly a certain set of SVG to be generated. Jasmine by itself gives us the tools to test our JavaScript code, including the ES 2015 stuff like classes. Angular 2 gives us the add-ons to Jasmine to help us with dependency injection and components. This is all pretty easy to understand and manage when we're talking about a handful of source code and a few unit tests, but real projects can have large numbers of source code files and hundreds or thousands of tests. Knowing which parts of your code are well tested and which aren't can become really complex in those situations. You might know that there are several tests for a particular component, but do you know if there are functions in that component or conditional code which is never getting tested by them? Istanbul was created to help you figure that out. It modifies JavaScript code so it can tell which lines got run and even different parts of complex conditional tests. Then it records that information and will generate reports that can show you how well tested your code is. It can show us our source code and which lines of code are touched by at least some tests. It can't tell us they're great tests, but it can tell us that at least there are some tests. One of the first things we have to consider, though, is that we've been using TypeScript throughout this course, and yet what we run in our browser and our unit tests is JavaScript, generated from that TypeScript. When we're looking at the code coverage, though, we want to see our original TypeScript, not how well the generated code is covered, so we're going to add one last tool to our unit testing to fix this for us. Remap Istanbul uses the source maps that we have in our generated JavaScript to do that. We installed it in the last video with all the other packages we need for testing. We also configured Karma to generate coverage information for the JavaScript code when we originally set it up. Now we're going to add one more task to Gulp so we can remap JavaScript code coverage to TypeScript code coverage. That's what we're doing here, and we'll add a single task to run both Karma and this. Now we can just run gulp test::unit instead, and we won't just get a count of succeeded and failed tests, we'll also get a report of how well our tests are covering our code. A report just like the one we saw earlier, except that it is for our original TypeScript code and not the generated JavaScript. We can drill into it to go through directories which group our code and down to the individual file level and see on a line-by-line level how many tests are running for a particular code. In this section, we have learned about tools to debug our apps in the browser. learned how to get started building unit tests for our TypeScript code, extended that to Angular 2 code, and finally, gotten reports about how much of our code is actually being tested. In the next section, we'll look at how to automatically build and deploy what we've developed. Hello and welcome to Deploying and Advanced Topics. In this section, we will look at using continuous integration, automation tools for your operations tasks, and creating disposable virtual machines you can use for testing. The first video of this section deals with continuous integration. In this video, we will look at what continuous integration is and why we want it. Then we'll look at some of your choices for a CI server and the prerequisites you have to meet before you can use it for your own projects. Of all the code, process, tools, and ideas I have or will talk about in this course, continuous integration, usually abbreviated CI, is the one piece you could live without, but only in one special case. If you're a solo developer working on the code all by yourself, you do not need it. However, as soon as you add even one more developer, you start breaking each other's code without realizing it. It's not broken on your machine. It's not broken on their machine. The code is only broken when all sets of changes are put together. That's where CI servers become valuable. They watch your version control repository, and when they see changes, they pull the code out, build it, and then run any tests associated with it. If either the build or the tests failed, they notified you of the failure, so you catch the problem immediately. For the last 5 years, I've used the Jenkins server to build my projects. It's popular with Java developers, but works well for all sorts of development work, and installation and maintenance of the software are both pretty easy. Sites like Bitnami, which help you get running servers up with the software you need, are even able to launch one in the cloud in a few minutes if you decide you would like to try it out. But not everybody wants to maintain servers, upgrade them, etc. If they did, then half of us wouldn't even have a job. So there are multiple companies out there which provide CI as a service for our building, testing, and deployment needs. The two most popular are CodeShip and Travis CI. Both offer free builds for open source software and charge for businesses which want to use their services. Implicit in the idea that you can use any of these tools is the idea that you're already using a version control system. The CI server has to have something it can watch for changes, and from which it can pull the latest version of the code. All of the code for this course is on GitHub, as are some other open source projects that I have done. That will be good for us when we want to hook up Travis CI in the next video, because it wants you to use GitHub. CodeShip can work with either GitHub or Bitbucket, and Jenkins can work with at least 50 different version control systems. The second thing you must have is an automated build. I've already shown you how to use Gulp to achieve that. One of the beautiful things about using CI servers is that as a project grows, you may have end-to-end test suites or other work which can take a long time to run. The sort of thing you do not want your local build tool to run every time you make a minor change to a TypeScript file. However, your CI server is a perfect environment for that. It can run time-consuming, CPU-eating build steps that nobody wants to run locally and still catch problems multiple times a day as developers update the version control system. You don't have to stop at just continuous integration. Once you have it running smoothly, you can work on a rich suite of tests, ones that you really trust to tell you whenever there are any problems in your application. With those, you can develop some confidence that any build of the software which passed the tests could be evaluated and deployed to the production servers. You may have to use feature flags which can be turned on and off to avoid users seeing a half-completed new feature, but if you can master that, you can do production deployments daily or weekly rather than have software deployments be a big monthly or quarterly event at 12 a.m. where pizza is provided for a bunch of already exhausted developers. Not that I'm saying I've ever worked at places that did that. Catching bugs early is a hallmark of having stable software, which can be shipped regularly to customers, and it's a high return on investment because you can usually set it up quickly and use it for weeks or months without having to change it. In this video, we've looked at why you would use a continuous integration server, seen what you have to have established before you can use one, like version control and a build system. In the next video, we will use Travis CI to run our builds automatically. In the previous video, we looked at what we get from continuous integration and the criteria we have to meet to start using it. In this video, we're going to take everything we just learned and put it into practice. To do so, we'll use a GitHub code repository, connect Travis CI to it, and tell Travis exactly how it needs to build our code. Then we'll update that repo and see Travis begin building it automatically. Since we've already built our workflow around Gulp, we want to be able to run Gulp on our CI server to both build everything and test it. Fortunately, Travis CI supports all of that. Before we do anything else, we authenticate to Travis using our GitHub account. That means that even before you start using Travis CI, you must create a GitHub account if you don't already have one. In GitHub, I've already created this repository to hold our code for this example. Now, let's connect Travis CI to that repository. It's literally as easy as flipping this switch to make Travis start watching for changes in the repo. Note, if you just created your repo recently, it won't show up in this list. Just go to the top of the page and click the Sync button, and it will show up in the list shortly thereafter. As Gulp uses our gulpfile.js, Travis looks for a file named .travis.yml in the root of our source code. Note, the dot at the beginning of the file name is important. When it finds it, it reads that to know how to set up an environment in which it can run our build, execute the tests, and perform any post-build actions we need to have happen. We haven't encountered the .yml format before, called YAML, but it won't be the last time we'll see it because in later videos, there's another tool I'm going to introduce you to which also uses it. If we look at the Travis docs for setting up a project based upon Node.js, we see that we have to tell Travis what language we're using and which version we need made available. That's simple enough. Travis gives us a virtual machine on which we can run everything. Naturally, that machine does not have all of our tools and packages installed on it, so we need to tell Travis how to do that. Now we've got to install the Node packages we need in order to run Gulp and all the tasks within it. Everything about this should seem familiar because they're like the instructions given way back in video 1.3 when you were first getting your machine ready to do some Angular development. We're now doing this for our Travis machine so we can build our code there. Switching gears momentarily, let's go back to our Gulp file. If we think back to what it does, you may recall that the default task is handy for the development we're doing on our local machines, but it's not really what we want here. The reason I say that is that if you look at the dependencies for the default task, you'll notice that it cleans out old files, starts up browser sync, and starts watching for changes to the files. None of that is appropriate for our build server though. Travis CI already handles watching for changes. Gulp isn't going to work with that. Browser sync is pointless because no browser will ever be used on the build server. Instead, what we'll do is add a different task just for Travis, which will only depend upon a couple of the tasks in our Gulp file. For example, the task which transpiles our TypeScript code. So we'll add a new task just for our CI builds. It will call the tasks which directly rebuild the code and then test it. Now our Gulp file still has a default task we use when developing and another one just for Travis CI. We'll upload everything in this directory to a repository on GitHub so it will be accessible to Travis. Now we'll add one final line to our .travis.yml file that tells it what we want to run. In this case, it's just Gulp running the specific task we created just for Travis. As much as I would like to add a tutorial on Git to this course, I'm afraid that is well outside the scope of what I'm covering here. Instead, I'll point you to GitHub's own Getting Started information and point out that Pact has more than half a dozen books and video courses devoted to Git. So if you're not already familiar with Git and its nomenclature of pushing files into repositories, I apologize. I really believe that you want to take the time to get familiar with it. It's the best version control system I've ever used. It's used by most of the big open source projects I'm familiar with, and Git is just a tool you need to have in your toolbox. Remember that Travis CI is already watching our repository for changes. I turned that on earlier. At this point, I can push all these files into GitHub and we should see Travis notice the change and trigger a build. And there, you see it. It noticed the change, checked out all the code, and immediately started the build process. In this video, we have set up an automated build system using the Travis CI service. Now, any number of developers could share the same repository, and build or test errors would be caught much more quickly. In the next video, we will create a server and look at tools we could use to automate its configuration. In the previous video, we looked at having our code built automatically, an important requirement when working in teams. In this video, we are going to take a look at how we can automate our operations tasks to avoid mistakes and recover from human error. We will both provision and configure a server in the cloud using Ansible. If you take nothing else from these next 3 videos, take this. I've found that automating the configuration of servers and deploying software to them to be almost as important as anything else to the successful start of a project. You do not have to use fancy tools. Even bash shell scripts like these, which I used for a project a couple of years ago, are better than nothing. If you don't automate operations, then you may find yourself reluctant to take down a server and make a new one, or do frequent deployments, or you will forget a critical step when you're in a hurry. That's because you're human, and so are the people running the cloud you may be using, and the internet between you and your customer. Even if you never make a mistake, others do, and automation helps make recovery from some mistakes easier. Automation isn't just about saving time, it's insurance against humans. First things first, I am no expert on this topic. What I'm going to recommend is a solution to development operations, often abbreviated DevOps. I'm not saying it's the only solution. There are literally dozens of highly sophisticated tools out there and whole companies devoted to this stuff. For example, Puppet, Chef, Salt, and the tool we'll be using here, Ansible. I'm not going to spend any real time on installing Ansible. It's very machine dependent because it requires that you have Python and SSH installed. That's standard stuff for Linux and Macs, not so much for Windows machines, so the installation is different. With that said, it's not hard to install. I was able to do it on this Mac in just a matter of a couple of commands, and it worked right away. There are several reasons I like Ansible for this work. I'm just going to list a few of them quickly, and then we're going to start putting it to some work. The first thing I like is that Ansible expects you to install it on only one control machine. All the managed nodes it will work with are going to be managed remotely using SSH and Python. You don't have to install software on those machines. That's not true for all the tools I mentioned before, but it's one of the things that makes Ansible easy to adopt. Second is that, like a lot of the best tools for this kind of work, Ansible is declarative. What that means is that you do not tell it step by step what commands you want done at the command line, as a shell script would do, but rather you tell it the end result you would like to see. An Ansible playbook says, I need this package installed, I need this Apache module turned on, etc. Ansible then looks at the current configuration and figures out if it needs to change anything to get it the way you want it. That ties directly to the third thing I like. Ansible is idempotent. That's a weird and obscure word for a fairly simple idea. It means that you can run the same playbook over and over again and you should still get the same result. It should not break just because the server is already in the target state, or even worse, undo what it did before. Again, this follows my theme of protect me from humans, especially myself. Before we begin using Ansible to do anything, we need a server, and since I don't have any hardware of my own out there on the internet, I'm going to use one of the many hosting companies out there. You've probably heard of Amazon Web Services, Rackspace, or DigitalOcean, but maybe you've never heard of any of them. I don't think I'm exaggerating a bit if I say that there are likely 100 or more out there. However, all of them are basically the same. You give them some money and you get a server that you can set up in the cloud. If you decide to create a server later and you aren't sure whether you want to use the same provider I'm going to use, I've provided a couple of useful links in the README to a site that provides lists of hosting providers and news about them, and another which runs benchmarks on the many different servers out there to try and help you pick one based upon various criteria. For this course, I'm going to create one over on DigitalOcean. At the time of this recording, DigitalOcean was offering a $10 credit if you created a new account, and that's enough to cover a full month of the server I'll be using here. I already have an account, so I just need to create a new server. You'll note that I'm using SSH keys to perform secure connections to the server, and I've provided a link in the course README to an article on DigitalOcean about setting that up if you've never done that before. Now that I've got a server, it's time to turn Ansible loose on it just to see what it can do. I've got to tell Ansible some basic information about how to connect to the server, but after that, it can do the rest by itself. Note that I did not install any software onto the server to make this work. The server is running stock Ubuntu 14.04. The fact that this works out of the box for Ansible speaks to why I like it. We've just gotten a completely configured server ready for our project to be deployed to it in a matter of minutes. I could actually have 2 servers or 200, and Ansible would be just as happy configuring them. By default, it would run that full playbook across all of them simultaneously, so it would not have taken much longer than it took to do just one. Or you can tell it to do smaller batches if you don't want to do every server all at once. Let's look briefly at the playbook we used and what it did to get that server ready. Obviously, your configuration may be very different from this, but the idea is the same no matter how you scale it. Ansible has huge numbers of modules to allow you to perform configuration against all kinds of Unix and Linux servers. Now, I did the server creation step manually, but you should know that Ansible actually has modules for many of the popular cloud providers. And if you needed to create and destroy servers regularly, it could do all of that too. In this video, we have learned both why you should automate all your server operations and seen how Ansible provides a low barrier to entry to start doing so. In the next video, we'll dig into the format of the Ansible playbook and build one to deploy some software to our newly configured server. In the previous video, we looked at DevOps tools and then focused on Ansible as a solution we will use. In this video, we're going to work through a series of steps to see Ansible talk to our server with only a few lines of configuration, then show how a playbook helps. Then learn more about playbooks from an example before creating one ourselves for deploying some software. To better understand what we did in the last video, we'll start from a simpler example. In this case, we're going to focus on 3 simple files which will tell Ansible enough to talk to a remote Linux server and let us know that everything worked. They are ansible.cfg, hosts, and ping.yml. Let's start with just the ansible.cfg file and the hosts file. Our ansible.cfg file is extremely basic and simply tells Ansible what user we expect to use by default when logging into remote servers, and the file to look in for the list of remote servers. The hosts file is likewise very simple. It's just a list of servers. In this case, the bracketed category allows me to tell Ansible a category of servers instead, and it knows that I'm referring to all the servers listed in that category when I want to run a task. Here, I've filled in the information for the server I provisioned on DigitalOcean in the last video. With those 2 files in place and nothing else, let's run Ansible from the command line and just perform a simple command to confirm that everything is working. That worked, but we don't want to do everything from the command line, so Ansible has the concept of playbooks. We saw those in the last video. This is a super simple playbook that would perform that same ping command. It's written in a format called YAML, and it's similar in many ways to the JSON you're already familiar with from JavaScript, except that indenting takes the place of the curly brackets and angle brackets you would see in JSON. Here's how we run the same thing using a playbook instead. Notice that we no longer have to specify the hosts on the command line, and the module to be used is in the playbook. In fact, the playbook could specify a whole series of tasks to be run, and it would still be run this same way. To see that, let's look at the config.yml file I used in the last video. As you can see, it specifies not one task, but several. It has a task to install several packages onto the server, to enable various Apache server modules, copies a file to the server, performs some Apache configuration, and then restarts Apache. Or does it? The important thing about all of this is that unlike a shell script, the modules being used here actually make some judgments before they start making server changes. If the software to be installed is already there, it doesn't try to install it again. If the Apache modules are already enabled, no commands are run to enable. If the configuration of the server doesn't end up changing, Apache is never restarted. That's what I was talking about in the last video when I said that Ansible is idempotent. It tries to do only what it really needs to do to get the server to the state I specified here, and then it stops. If everything is already done, it changes nothing. Now let's create a new deploy.yml file to deploy some files to the server we configured in the last file. Obviously, we need something to deploy to our server, and what better than the exact same piece of code we were building with our continuous integration server just a couple of videos back. Let's deploy the same code we built in video 7.2 to the server and make sure it works. The playbook couldn't be much simpler. The first few lines are the same as they were in the config.yml. They tell Ansible which set of servers we're interested in and the name of the site we intend to deploy. Then there's a single task which uses Git to pull out everything to the server directory which Apache is serving up whenever we hit the server. We'll run that with Ansible-playbook deploy.yml and then check to make sure our new site works as well as we think it will. Before we finish up our look at Ansible, I want to point to a couple of resources you'll be using often. The first is the complete list of modules provided by Ansible. It's a long list, but by no means complete. If you can't find a module from Ansible which does what you need, be sure to look around for a third-party piece which does. That's where the next site comes in. It's Ansible Galaxy, and it's also an official Ansible site. It catalogs many different playbooks and roles, reusable pieces from your playbooks, that can help fill in any gaps you need filled. In this video, we have looked at the files Ansible uses to do our DevOps work. We started from a minimal example, examined a more complicated playbook, and then created a third playbook which handled a software deployment. In the next video, we will look at how we can run local servers to test out our playbooks without having to pay for the privilege of doing so. Welcome to this, the final video in our series. In the previous video, we looked at using Ansible to do our software deployment. In this video, we're going to take a look at creating disposable servers as needed using VirtualBox and Vagrant. If you're like me, you can look at the servers we've been using for the last couple of videos, servers which literally cost pennies per hour, and it still nags at you that you're paying to work out the kinks in Ansible configurations. Clearly, it's something wrong with me. But if I fix that problem, I also have a tool I can use in other ways as well. So let's see what tools could help out here. Instead of renting server time to try out your configuration and deployment scripts, consider instead setting up some temporary servers using a virtual machine tool like VirtualBox from Oracle. It's free and works well. Using it, you can run a local copy of the same version of Linux you intend to run on your servers and launch all your Ansible playbooks against it until they're perfect. I could do all that manually. Download VirtualBox, start one up, install Ubuntu on it, then run Ansible against that. But that can get tedious in a hurry. Vagrant is a really cool tool which wraps VirtualBox and gives me the ability to create a server and tear it down with just a couple of commands. That's much more helpful for me. After installing both VirtualBox and Vagrant, I will go to a directory with a Vagrant file I've already created. This is a very simple one. If you look past all the comments in the file, you'll see that it only does three things. It tells Vagrant what operating system we want installed on the VM it's going to create. Ubuntu 14.04 in this case. We're going to move port 80 on the VM to port 3141 locally, so it won't collide with anything my machine might have on port 80. And finally, it's going to set the memory on that virtual machine to match what the DigitalOcean servers we've been using had. That way, any playbooks we test on this virtual machine should act the same way. At this point, we can now get Vagrant to create a new box for our testing by simply typing Vagrant up. It will find the local Vagrant file. Notice that it doesn't have the operating system you want to install, so it will download it and then start up a virtual machine running it in a matter of minutes. The next time you run it, it won't need to download the OS again, and at least on my machine, it can start up a fresh server in about 60 seconds. To see that it is currently running silently in the background, we can run vagrant SSH to connect with it and access it the same way we would one of our remote servers. With that working, we need to tell Ansible about our new server. I've already created a test hosts file, just like our host file. This will probably work for you without any changes. If it doesn't, you can use some information from vagrant ssh-config in order to fix the values here, but mine proved to be consistent no matter how many times I created and destroyed the vagrant server. Also note that I've made a small change to the ansible.cfg file to tell it to stop checking for consistent SSH keys on the host. Vagrant will create new keys every time it creates a new server, so those will change over and over again. Without this flag, Ansible will likely have problems the first time you destroy a vagrant server and try to connect to a new one. Now, the last time we ran our configuration playbook, we did it with ansible-playbook configure.yml. That used the defaults from ansible.cfg, which are the host files and the root user, but we cannot use those values with our new vagrant server. So we're going to make a couple of tiny changes to the command line to tell Ansible to use our new host file and the -b option, which tells Ansible to become root after logging in. Deploying works exactly the same way. And we can test the results by hitting the port we told Vagrant to use instead of port 80 earlier. A quick command to destroy Vagrant and the virtual server we created in minutes earlier is gone just as easily. We can create and destroy them locally as much as we need to work out any aspect of coding we might need to do. You can't tell me that's not useful. In this section, we have learned about build servers, which can integrate the code from many developers as they make changes, started using Ansible to power our DevOps, and touched on using Vagrant to create disposable servers as needed for testing. I'm a big believer in the idea that success breeds success. In this course, you've learned Angular 2, used Gulp for builds, learned about structuring your apps, testing them, and DevOps using Ansible. You've already had a great many successful moments. It's now time to use what you've learned and build something new. With that in mind, please consult the README I provided with this course for links to all the software I've used in it, help on finding hosting for the software you are going to build, and even some further reading on topics like ES 2015. From Pact Publishing and myself, John Munch, thank you so much for purchasing this course. I hope you've enjoyed it.